Okay, this is another question on projections of straight lines. As I've said in the previous videos that I uploaded, I explained that projections of straight lines have to do with the construction of the front view, top view and end view of a straight line, and I've explained how that can be done in the first video that I uploaded. Now, this question says that the top view of a straight line AB, 72 millimeters long, measures 62 millimeters, while length of its front view is 49 millimeters. Its end A is in the vertical plane and 12 millimeters above the horizontal plane. Draw the projections of the straight line and determine its true inclinations with horizontal plane and vertical plane. So that is the question. Now let's look at how this problem can be solved. The first thing that you need to do here is to draw the XY line. So draw the XY line like this. So this is XY line and this is X and this is Y. Then the next thing that you need to do is to take your set square. So set at this point and make a short vertical line, so you can see it there. And then the next thing that we need to do, as we are told in the question that the end A of that straight line is 12 millimeters above the horizontal plane. As I've said in the previous video, that when you have something like that, that the end of that line is at a particular distance above the horizontal plane, so that distance will be taken in the vertical plane. So let me show you what we have here. This is my vertical plane, as I've said it before in the previous video, and this is my horizontal plane. Alright, so I believe you still remember this. So you take a measurement of 12 millimeters from this point on XY line, take a measurement of 12 millimeters up the vertical plane. So this is it. So this is 12 millimeters. Then this point, you call it A prime. So this point is A prime. Then from this point, draw a horizontal line. Okay. Now, after you have drawn the horizontal line on this point, as we are told that the top view of line AB, the top view of line AB is 62 millimeters. So take a measurement of 62 millimeters from this point A prime. So take measurement of 62 millimeters. So here is 62. And then we are also told that the front view is 49 millimeters. Then also take a measurement of 49 millimeters on this line. So this is 49 millimeters. Alright, so the next thing that you need to do is that, so call this point here where this 62 millimeters end, call it B1. And this point here where 49 millimeters end, call it B1 prime. So call it B1 prime. Alright, so from B1 here, where the 62 millimeters end, draw a vertical line. So the vertical line goes like this. So it goes like this. Alright, then take your compass and take a measurement of 72 millimeters, which is the length of the line itself. Take a measurement of 72 millimeters on your ruler. Then put it at this point A prime here and make an arc on this line like this. Alright, so wherever the arc touch on this vertical line, call it B2. Call this B2. So this is B2. Then connect A prime and B2, connect them together. So this line A prime B2 is the true length of the line AB, which is equal to 72 mm or 72 millimeters. So this is equal to 72. So it's the true length of the line. Now, so the next thing that you need to do is that from point B2 on the vertical line, draw a locus line. So draw a locus line. So let's call this locus line, let's call it locus line N prime. N prime. Alright, so the next thing that you need to do is that take your compass, put it at point A prime here, and extend it to B1 prime. Extend to B1 prime. Don't forget that B1 prime is the length of the front view of the line, which is equal to 49 millimeters. 49 millimeters. So put it at this point. So extend it to B1 prime and draw an arc like this. So whenever the arc touch on the locus, whenever it touch on the locus, call it B prime. So this is B prime. So join A prime B prime together. Join A prime B prime together with a straight line. Alright, so this is it. So this A prime B prime is the front view of line AB. And this line A prime B prime is equal to 49 millimeters. It's equal to 49 millimeters. So, okay, so the next thing that we are going to do is that we need to draw this line 72 mm. We need to draw it on the horizontal plane, and also the top view of the line, we have to draw it on the horizontal plane. But before that, as we are told in the question that we should determine the true inclinations of the line, so the angle that this line A prime B2 makes with this horizontal line is one of the true inclinations that we are asked to determine. And this angle here, this angle here is the true inclination to the horizontal plane. It's true inclination to the horizontal plane. So I will come back to this to take a measurement of this angle. But let me call it theta. Let me call it theta 1. That is theta 1. So this theta 1 is the true inclination to the horizontal plane. True inclination to the horizontal plane. To draw the top view now, this is the front view. This line A prime B prime is the front view. So to draw the top view, so from this point, from point B prime here, put your set square there and draw a vertical line like this. So draw a vertical line. So after you have drawn the vertical line, also extend this line, bring this line from B1, this vertical line from B1, bring it down to the XY line like this. Bring it down to the XY line. Is it? So bring it down to the XY line. Then don't forget that the distance A prime B prime is 62 millimeters. So take your compass put it on this XY line at this point, and actually this point on XY line should be our point A. So this is point A. So put your compass at point A here, as we are told that the end A is on vertical plane, So put it at this point. This is a point on the vertical plane. So put it at this point and extend it to this point. Then draw an arc. That goes like this. So wherever the arc touch on this vertical line that you draw down from the B prime, so call it B. So call it point B. So this is point B. Okay, so from this point B now, so we are going to join A and B together. So point A and B, join them together with a straight line. Join AB together with a straight line. So it goes okay. So this line AB is the top view of the line. So this is top view of the line, and it is equal to 62 millimeters. If you take the measurement of the line, this is 62 millimeters. If you take the measurement of the line, so this will give you 62 millimeters. Okay, so we have drawn the top view. This is the top view of the line. So and this is the front view of the line. So we need to draw this same line of length 72 millimeters, which is the true length of the line AB. Okay, that we are asked to draw its projections. So we have actually drawn the projections of the line, but we need to draw this line. We need to also to draw it here so that we can get the true inclination of the line to the vertical plane. Okay, so what you need to do now is that take your set square, put it at this point. Put it at this point, but before that, draw the locus here as we did in the vertical plane. Draw the locus. So call this locus. So call it. This is M, and this is M prime. Okay. Now, then take your ruler. So from this point B1 prime, draw a vertical line down. So whenever this vertical line touch on this locus MM prime, call it point B2. This should be B2 prime. So this is B2. Now join A, B2 together. Join A, B2 together to get the length of the line, or the true length of the line. Alright, so we take the measurement of this line, it will give you 72 millimeters. This is it. This is 72 millimeters. Alright, so this is also the true length of the line, and it is equal to 72 millimeters. So now, so the true inclination, that is the angle that this line AB2 makes with the vertical plane. So put your set square, your compass here, and draw an angle, or draw an arc to form that angle. So call this angle, call it theta 2. Alright, so we have drawn the projections of the line, which is, we have the front view A prime B prime, and we have the top view AB. So then we have answered that. So the next thing that we need to do here is to measure the true inclinations of the line to the horizontal plane and to the vertical plane. So this theta 1 is the angle that the line makes with the horizontal plane. So we have this angle that the line makes with the horizontal plane, we have it on the vertical plane here. And then the angle that the line makes with the vertical plane, we have it on the horizontal plane, which is theta 2. So we are going to take the measurement. So I will take the measurement. So if I take the measurement here with the use of my protractor, so this is it. I believe you know how to do that. So this angle is 30 degrees. So theta 1 is 30 degrees, which is the angle that the line makes with the horizontal plane. So that is taken in the vertical plane. Then the angle that the line makes with the vertical plane, which is in the horizontal plane, so we have it here. So this angle, so if I take the measurement, so I have this to be 47 degrees. 47 degrees. Okay, so this is the solution to the problem. So I've written it here. So inclination with horizontal plane theta 1 is equal to 30 degrees, and inclinations with the vertical plane theta 2 equals 47 degrees. So this is the solution to the problem. So thank you for listening. God bless you.